Okay, I think we're ready to start. So this next section, the rich type system, really breaks down the different kinds of types that you have to use in the system and when you should use one over the other. This is definitely a case where what I am trying to do is equip you to have the arguments with your teammates around what's the most appropriate type to use in any given context. So this is the Brad Abrams view of the kinds of types in the system. So it may not match anybody else's, but I think this view kind of helps to understand the decision making on when to use what kinds of types. So when I say types, that's the high level principle. And then there are two kinds of types. There are reference types and value types, and we'll talk about the difference in some depth in a minute. But all reference types, there are a bunch of different kinds of reference types, and we'll drill into when to use each one of those kinds of reference types. And then there are value types, and we'll talk about when to use the different kinds of value types. Okay, so just the high-level principle, the first spot in the decision tree was when to use reference types and when to use value types. So the first thing to recognize is that reference types are allocated on the GC heap. They're managed by the garbage collector, and they are essentially a pointer. When you have a reference type, an instance of a reference type, it's actually what you're holding on to is a pointer to some memory that the GC is managing. And that means that assignments all it does is copy the reference or copies the pointer from place to place. So you could have this hugely large reference type in memory, and you assign that to a bunch of different variables. It would just assign the pointer to that location to a bunch of different variables. So there's not a huge expense there. When you create an array of a reference type, those arrays are actually arrays of pointers to the actual memory, or they're arrays of references rather than the actual data. So I call that allocating out of line. So they're not kind of embedded in the structure. They're an array of pointers. And then they're passed by reference by default. So when you call a method, it's very similar to assigning a variable. You actually pass the reference or the pointer rather than the entire object. So value types are the exact opposite. So value types are allocated on the stack. They are assignments are copied by value. So when you have a value type and you assign it from one variable to another, instances of that value type from one variable to another, then you're copying that entire value type around in memory. And arrays of them, the array is actually allocated in line. So the array is contiguous memory. And then when you pass by value. So by default, it actually copies the value when you pass. So it's kind of the high-level difference between reference types and value types. So one great magic thing in the system is that, actually it's interesting as I interact with developers, it's amazing how many of our developers can be very productive in our system without deeply understanding the value and reference type distinction. And I actually think that's a good thing. Now, I think you, as people building parts of the platform, need to really deeply understand it because there's some performance impacts, but most of our developers don't necessarily need to know the difference. And this boxing thing is one of the reasons they don't need to know that. It's because whenever it's needed, a value type can be transformed by the runtime into a reference type through a process called boxing. And what boxing does is it allocates a box or allocates some bit of memory on the GC heap and copies that data from the value type into that box. And unboxing is the reverse operation, where it checks makes sure that you can safely unbox, and then it copies the data out of memory back onto the stack. And that lets you be able to write code like this, where you have an integer, which is a value type, 1, 2, 3, and then you cast it to an object, and notice that was a seamless operation. That does a box, and you can see in the second line there what you have now is O as a reference or a pointer to a spot in memory that has the value 1, 2, 3, and that also references the type of system, that N32. And then the next line there, int J gets O cast to int. And that does the unbox. That copies 1, 2, 3 out of memory and back onto the stack. So the important thing to take away from here is that there is actually some overhead involved in doing this. Those 3 lines look kind of innocuous, but there's actually some memory allocations going on. Overall, those are small, short-lived objects. It's not a big deal. But if you're doing this thing in a tight loop on behalf of the user, then that might become a problem. So you might have to watch for that. And we'll get into more of that when we talk about the performance section. Okay, so I talked about what value and reference types are and how they interrelate. And now I'm going to talk about when should you use one or the other. So value types, you should use value types when the first pivot to me is when you have value semantics. When you're doing something like modeling a new kind of data type. When you're doing something that that if it were up to you, you would add a new kind of language keyword in C# for. You know, just like they have ints today, you would add something like that. That's a good thing for a value type if the kind of scope of usage, if you always want to copy this thing around when it's used, that indicates it has value semantics. A rule of thumb here, it's just a rule of thumb. It's not a technical limitation. But the rule of thumb is when you get above 16 bytes, that's when we start to feel like the overhead of doing this copying around every time it's used becomes prohibitive. That becomes like a real issue. So if you feel like the value type will ever in its life get bigger than 16 bytes, then you should model that thing as a reference type. And they're also typically immutable. They don't have to be, but because of the way the runtime and language treats them, value types are typically behave more predictably if they're immutable. And the other thing is if they're immutable, it helps me believe you that they really have value semantics. So when somebody asks me about int, is int immutable? Is int I, is I immutable? Yeah, it's immutable. I mean, you can say I gets 5, and then you can say I gets I plus 1, but then you've changed, it's no longer 5, now it's 6. You can't like add 1 to 5. You can't change the 5-ness of 5. So anyway, it's probably, Rahul, what I really mean by immutable is that when you're writing your value types, don't have any way to change the state, to publicly change the state of the object. No setters, no methods that have a side effect of changing the state. And that will give you immutability. And then it's simple. Use reference types everywhere else. So essentially, by default, you should use reference types. And then only if you have a need to should you use value types. Somebody asked me about, well, should I use value types? They essentially, I mean, they didn't say these words, but what they meant was, I don't trust the garbage collector, so I'm going to use value types everywhere else. Everywhere. Okay, well, I mean, we can have a conversation about whether you should trust the garbage collector or not, but using value types everywhere is not actually going to give you a more efficient system. If the value types are large, you're going to be copying those things all the time. And more importantly, it won't be consistent with the rest of the framework, the rest of the platform that you're plugging into. Okay, so now we're going to drill a little bit into the value types and understand that there's structs and enums. And I'm going to talk a little bit more about what those are and how they interact. So structs are like N32 is just an example, and I included this one for a couple of reasons. One is I think it's very cool that the keyword in Visual Basic, integer, and C# int map directly to this N32 type. That is a struct that looks just like the structs that you can type in and use. There's nothing magic and special about the actual type N32 in terms of the class definition. So it's public struct in32. It implements a couple of interfaces. I-comparable, I-formatable, so structures can implement interfaces. So they act like primitive types. I already mentioned have a small instance size and all this stuff. Okay, so one kind of gotcha around structs that I wanted to bring out is this, what happens when you create arrays of structures. So I create some structure that you've created, and I create a new array of 10 of them. And then I indexed into the first one, and I start to check the values that are in it. What will I find out about it? If I can have a constructor on my struct that initializes its state to something, but did that constructor get run when my struct was called? When the array was allocated? Yeah, that's right. So what he says is it just initializes the space for it. That's almost complete. What it does is it zeros the memory. It sets everything to quote 0, and allocates the memory for it out of there. So that means your constructor never ran. You wrote this nice, pretty constructor. It never ran. So that means that people can get a hold of your instances of structs that never had your constructor run of them. So if you're depending on some code in your constructor to run to do something, then it may not in some cases. So you have to design to make sure that 0 state is meaningful. So by the 0 state, I mean any integers or doubles or floats would all be 0. Any references would all be null. So that's what the 0 type's about, 0 state's about. So I think C# and I believe VB have a very cool way of getting around this problem, such that it turns out I've never seen it be a real world problem, even though you might think it might show up. Anybody know how the creative way C# gets around this? Can you have a default constructor on a struct? Anybody? Deep C# knowledge. So C# will not actually, C# doesn't actually let you define a default constructor. They just say the default constructor is provided for you, and guess what it does? It zeros the state. So it's basically the same deal. So the C# language spec doesn't have to say, oh, sometimes the structure may not, be. It just says the default constructor is always run, and it may not actually be run. The CLR might zero the memory, but the same results happen. Okay, so enums. So just an example of an enum here. Enums are very similar to C++ enums. So if you're familiar with C++ enums, then you know about 85% of what we're doing with enums in the CLR. I think the most important bit about enums is that all integral values are legal. All enums is they're an alias mechanism. You can give a kind of a stringified identifier to integers. That's all they are. There's no strong kind of typing there. So what that means is that and I'll have a slide on, but you can pass any integer value into a variable that takes an enum, or a property that takes an enum. So they are always scoped by name. So you can, at least in C# and VB, you always specify the name, and so you should assume that the name is being specified. So like in C++, oftentimes the enum name, all the enum members are prefixed with the enum name. So you don't need to do that because you'll always have colors.red, colors.green, colors.blue. You don't need to say colors color red, colors color blue, which you needed to in C++ because they all got put into the same namespace. The other important thing is that performance is just like performance of the underlying type. In fact, the CLR, the JIT engine doesn't actually know it's an enum. It actually just thinks it's an integer, kind of throws the enum information away when the JIT starts working on it. So there's no kind of performance argument for why one should take an int instead of an enum. So a lot of times I see that in APIs, reviewing some APIs, and there's this int flags parameter. And we'll go, int flags, so what does that mean? Oh, yeah, the developer passes in -72 to mean that the disk should be formatted, and 17 to mean that you know, the disk should be defragged, and 14, and you go, well, where do those numbers come from? Oh, those numbers match the you know, int heap, blah, blah, blah. And it turns out developers will never know that. It's so much better to provide an enum that directly names those constants that developers can just pass in. And there's no performance penalty for it. So, and I think that's true even of Booleans. You know, people are like, well, 2-value enums, that's, I know for a fact it's only ever going to be 2 values. Well, you know, why should I pass an enum there? I just use true and false. The problem is when you're reading code, what does it look like to code against? You know, I was reading some sample code, and it's like file.open foo.text, comma, true, comma, false, comma, true. Like, oh, true, comma, false, I think what you meant was false, comma, true, right? I don't know. What is, you know, what do those things mean? If you're code reviewing that thing, the parameter name, however great it was, is now gone. All you're doing is looking at the code. You don't know. It's much better to, even if it's a 2-value enum, to actually spell that thing out.
But then you have to do error checking on the function to verify that the thing is not out of your...
That's true. So his comment is then you're going to have to do error checking. That's true. We're going to talk about error checking in a minute. And that's where, I mean, that's where everything in life is a set of trade-offs, right? So the error checking, because there's 2 pushbacks to it. One is it's hard for you, the developer doing, building the next generation of Microsoft platforms. It's more code for you have to write to do that error checking. I got no sympathy for that. You know, like, you are a professional developer. You can do the error checking. The second argument is kind of a performance argument. Like, it's expensive to do the error checking. Like, I have to do a couple of if branches. And that's true. And in some APIs, a couple of if branches really matter. And it's an important issue. But in the vast majority of APIs, my response to that is, OK, can you show me the real-world scenario where that shows up in kind of an LOP log or some kind of benchmark? And if you can't, then you know, yes, it's technically more. In some micro benchmark, you might have a problem. But if it doesn't show up in a reasonable test case, then it doesn't matter. I mean, if the next thing you do after you do this checking is you go off over the network and, you know, check the existence of a DNS server, then the overhead of doing the checking is infinitesimal compared to the network. Yeah. So his question is, why don't we do the automatic checking to make sure the values are in the enum? Well, it's to give us the performance. So if we did the automatic checking, then the runtime and JIT would have to know those things are different than ints, and it would become more costly to use enums. And then I'd have to be telling you things like, well, you use enums in these cases and not these cases, and it might be net worse for developers. But we can talk about it some more. That might be a good kind of panel discussion question. So as a couple of you have mentioned, you do have to validate the enum arguments because this line of code on the screen is 100% verifiable. It works in semi-trusted code. It'll compile. It's quote legal code, but you should kind of be aware of it and validate for it. So don't suffix enums with enum suffix. We kind of played around with that for a while, but the problem with the enum suffix is that you always have to mention these enum names. You have to say, it would have to be file mode enum dot open or whatever, and having the enum repeated all the time doesn't actually kind of add any value. Okay, so I want to do, I have a couple of slides in the deck that are of this format with this kind of arrow. And what I'm doing here is showing you kind of what the expanded view of the type really is, because I think as a framework developer, because you're building part of the platform API, you really have to understand kind of what's going on at least one level beneath you. So you type in code in the top box, and the compiler / runtime generates code in the bottom box, is the way to think about it. And the important thing, a couple important things to highlight here. So you typed in this compression enum, zip, super zip, none. And then what the compiler does on your behalf is it creates this struct called compression that inherits from enum. So first kind of interesting note, it's kind of cool. It's the only way to get a struct that inherits from something other than value type. This is no value type, is this way, so it's kind of cool. And then the next thing you'll notice is that public int value underscore underscore. So what that is an instance. Notice it's an instance field. That's where the actual value of the enum is stored. So that it always matches the underlying type of the enum. And that's what the runtime or JIT sees. Whenever it sees your enum, it just goes right for that value field, and it just uses that. And then you see a couple of public const things, and they're of type compression. And it's important that they're of type compression because you actually want to pass those to APIs that take a compression, right? My API is typed to take compression. I want to pass compression.zip. So zip needs to be of type compression. And then you see that there's some order has been given to them, 0, 1, and 2. Like, where did those numbers come from? The C# compiler just made those numbers up based on the order that you had in your source code. And also notice that those are const. We'll talk a little bit more about it when we get to fields this afternoon. But const, if you remember, can never change every time. They're burnt in at compile time. So that means if you get an enterprising young intern come in and he gets a copy of the coding conventions that I'll send out, it actually says that you should alphabetize your code, which I think is a fine idea, unless you've already shipped it. Because if you've already shipped it, then if you alphabetize this code, what will happen is you'll change the order of it. You'll go none, super zip, zip. And then the next time you recompile it, it'll change the order of those variables, and that'll be a breaking change. Be a very hard one to find out. So, of course, the easiest way to work around that, though, is the compiler lets you specify the defaults. So you can say zip's going to be 7, super zip 12, and none 0, and that works just fine. Yeah. Yes. So how did I generate the under the covers code is essentially what he's asking. I used ILDASM, and it ships with the SDK, and you use ILDASM assembly name, and you pop it up, and it shows you the IL. And then I guess I'm sort of familiar enough with it, I generated back the C# code from it. But you can, I mean, even if you're only loosely familiar with it, you can get a sense for what's going on.
Back to the error checking, a nice way would be if enum had a static sort of like belongs member, like does this belong? So you could always follow that.
Yes. So his question is, it would be nice if enum had a belongs member. Yes. So we're working on a couple of things in that space. It turns out it's a little bit harder than you might expect because that would have to be something the compiler actually generates based on what you have, and we have 26 compilers to worry about. So that's a bit hard, but we are working on some stuff in that space. Okay, so I think I covered all this. Okay, sorry.
You said that you need to use enum instead of constants. If I want to have constants that are, for example, exclusive, I want to do an XOR or an AND operation on them. Shouldn't I use constants instead of enums, or I have to specify the value of enums?
So your question is, I have some constants I want to XOR, do some ANDs on. Should I use enums or constants? Let me finish the section on enums and see if it addresses your question. If not, we can redo it. Yeah, I think I talked about most of this stuff here. Okay, so flags kind of gets it at what you're discussing. There's truthfully, there's two kinds of enums. There's sort of enums, and then there are flags or bit fields, as some people call them, enums. And what they are, they're enums that are intended to be ORed together. You're intended to specify more than one at a time. And for these, at powers of 2, I think it should be obvious to OR those things together. We also use a plural name in this case to highlight the fact, to kind of signal to developers that, hey, you actually have the option of passing more than one value here. So, for example, we have attribute targets rather than attribute target. And then the other thing to recognize is that the vast majority of our users, you're way over their heads. You're talking about bitwise ORing these things together. Like, they're not going to get it. IntelliSense doesn't today do a good job leading them down that road, and the whole concept is not one that they're likely to get. So that doesn't mean you can't do it. What it means is that you should just provide the common defaults. I mean, you know what the 80-20 is here. You know what the 80% case is and what the 20% case is. For the 80% case, just provide named constants that already do that. It's not really, it's infinitesimally more expensive in terms of the size of the class, and provides a way where the developer doesn't actually have to OR those things in. So, for example, in my case, I have both class and struct. And, I think it's very common to have a custom attribute that'll work on classes or structs. So I'll just provide a member for that called type. And I'll do the bitwise ORing so my developer doesn't have to. But I do have a little red flag around, a red flag around flags. And that is that flags, I think, can be easily abused. They're one of these kind of, you give people a little more power and they can abuse it a little bit more. And what tends to happen with flags is you go, oh, yeah, well, we already have a flag we're passing to this API. Let's just strug this other bit in there, and that bit, and that bit, and that bit. And it kind of gets to a general principle I have in terms of class design, which we'll talk about more later. But every class, enum or value type, whatever, every class should have a set of responsibilities, have a kind of single thing it does, and you shouldn't kind of murky it with a bunch of different things. So I think attribute targets is fine. It has a single thing. It's about specifying where an attribute goes. But then when I look at another API that I was involved with in Reflection, we have this binding flags enum. So we have this binding flags enum. Are people familiar with that? Who's familiar with Reflection binding flags? Okay. So without even me explaining it, can anybody say what they don't like about it, or? No? Okay. Maybe I'm the only one it bugs. But the thing that I think is crazy about binding flags is it specifies every option you might want to pass to invoke, whether they're related or not. Right? The whole, is it static or is it instance? Is it public? Is it private? Is it property or a method? Is it, gosh, a bunch of different things. Should we use this kind of binder or that kind of binder? And the argument that we had at the time was, well, it would be more expensive to pass another enum. There are unused combinations in this 32-bit value. Let's continue to use those unused combinations. And that's a technically correct argument, but from a user point of view, there's a bit of a problem with that. Users have to struggle with getting the exact right combinations of the binding flags to make it work. I think it would have been better to have a very few set of enums that encapsulates kind of more logically what we want to represent out of binding flags. And in fact, we found other places in the system where we'd like to have an enum that specifies accessibility levels. But we don't have such an enum because it's kind of glommed in with this binding flag enum. Yep. Okay, so did that address your bit fields question? Okay, beautiful. All right, so pressing on here, classes. Classes are by far the most common thing to use in the system. The default thing you should use is a class. For the core classes in your system, you should have some things that represent what I'll call concrete or common objects that developers can actually associate with. So an example of it is in the system.io namespace, we have a thing called file because that's a, quote, concrete thing that developers kind of experience in their real world, and so they feel comfortable using that. Now, we also have some abstract kind of data structure-y or computer science-y called a stream, and readers and writers, and those are important too. I'm not saying we just have this dumbed-down object model, but it's important to have kind of a mixture of those two. And I typically see API designers that are out of balance in one or the other of those areas. Either all they have is these concrete things, and those guys are typically in the tools division, or all they have is these kind of low-level geeky data structure things, and those guys are usually in the OS division. So the truth is we actually need the best of both of those things. Okay, so I want to spend a couple of minutes talking about generics. They're kind of a new space for us in the system. We're adding templatized types in V2O of the .NET framework. And essentially what it does is, you know how methods today, you can have methods with no arguments, or you can have methods that take arguments. And boy, methods that take arguments are so much more powerful than methods that don't take arguments. You can do so much more things, so many more things. And so that's the same thing we're doing with types. Now we have types that can take arguments, if you will. And the arguments that a type can take are the types that it can work over. So I think collections are the best example. Today we have array list in the system. And it is essentially typeless. You stick stuff in there, and all it really knows about is objects. So you lose your typing information. But with generics, I can actually have a list that keeps the typing information, and we'll look at an example of that. So if you use C++ templates, it's conceptually similar, but it's different in that C++ templates and actually Java's GJ, or the generic support that Java's adding, are both kind of compile time evaluated, and that information, it uses erasures, so that information is lost at runtime. So we don't, runtime doesn't have that information, but in the CLR, we preserve the information at runtime. We actually added new metadata tables, new IL instructions to preserve the typing information, which gives us, I think, a better developer experience. So we are in the middle of phasing generics in. So I talked about CLS. So today, with WDB, generics are not in the CLS. We're giving our third-party language vendors some time to kind of catch up, absorb generics. But in Longhorn, when we ship the WinFX, generics will be in the CLS. So if you're working in that time frame, you should feel free to use generics. Okay, so let's talk a little bit about what generics are. So here's an example of a list that I wrote. This is what you would write today for a list. And you would write this list even if you knew you were going to store ints into it. And what you do in the little boxes, if you were calling it, I would pass it, 1 and 2, and those guys would get boxed, right? Because I'm passing to an object. So, and that might be a performance problem. If I'm doing a whole bunch of those, it could become a performance problem. And then one that I think is a real problem is if somebody's confused and they pass in the string 3 instead, they don't get a compile error for that, right? But I guarantee you're going to get an error somewhere. Somewhere you're fishing values out of that list, and you're going to get some kind of bizarre cast exception, and then you're going to have to debug and find out who the guy was that tried to pass the string in there. So that's a problem. And then you have to write this really ugly code when you want to cast values out. And so it's ugly code, and it's a bit inefficient to take a value out as an object, cast it back to an integer. So that's kind of frustrating. And it turns out what most people did in the frameworks is we created somewhere close to 80 of these strongly typed collections where we wrote our own collection code and just typed every, instead of replaced object with the appropriate type. So developers wouldn't have to do that. And that was buggy and error prone. We're still facing problems where the enumerator of this kind of collection works different than that kind of collection, and that's a problem. So what does generics do? Well, with generics, notice now I've templatized the type of list as list of T. And now everywhere I had object before, I have T now. So instead of being an array of objects, it's an array of T's. Whatever you're going to give me as a T, I can create an array of that, whether it's a value type or reference type. The add method is going to take a T. The indexer returns a T. And now look at my usage code. I do list of T. That's how we read that. List of T gets new list of T. So now, list of integer gets new list of integer. So now I know my list contains integers. It's the only thing get put in there. The runtime knows that. It'll kick anything out that doesn't have it. The compiler knows that, and it'll give you an error right away. You're 100% guaranteed that anything in that int list is going to be an integer. So now 1 and 2 can be passed with no boxing. There's no need to box. The underlying array is of type integer. And now when I try to type in quote 3, I get a compiler error immediately that tells me, hey, you're passing a string where an int's required. And I go, oh, okay, and I fix it. And it's so much cheaper for me to fix it there than to debug it much later in the code. And then get sucking values out. It's very simple. So that's generics in a nutshell. So why would you use generics? So I've already mentioned a bunch of it, but it's essentially that a good segment, a good swatch of our users really appreciate strongly typed APIs. APIs where what they'll tell you is, I appreciate an API where IntelliSense, where the IDE kind of helps me along and helps me decide what the next thing to pass is. And when they, you'll see a clip later, when all you have is the type is object, or you didn't tell the developer anything. They don't have anything to go off of. It's much better to have to do strong typing. And I already mentioned the promotes consistency thing. So now we have one implementation of list, and we have one developer on it. We're going to get that thing right, and then everybody can use it across the system. And you, who are an expert in like Windows management infrastructure, great. You don't have to concern yourself with how to implement an enumerator that will reverse correctly, for example. Right? That kind of thing will be done on your behalf. And in many cases, it can increase performance. We're going to drill into that in a little bit more. And there's less code for you to write and maintain, and less code's typically better. Okay, so some defining generic APIs. So whenever you have APIs today that are loosely typed, that are typed to take object, and you find yourself always having to cast in and out of those, you should ask yourself the question, is it worth taking generics there? So we do use single letters for the generic type. So it's a list of T, not a list of item type. We wrestle with this a fair amount, but the reason is we really wanted these generic types to stand out as something different. They're not like a regular type. They're not like a regular variable. We wanted them to stand out and feel different. And we also wanted a little bit to constrain the use of generics. So generics should be used when the type has a pretty obvious usage associated. If you find yourself needing to provide a name, like, wow, I need to provide a name for this, then I think maybe you're reaching too far with too complex a use of generics. So don't place generic types in special generic namespaces. We've had to do that for legacy reasons with system.collections.generics, but generally speaking, they're just part of the system, and they should go into whatever namespace is appropriate. Okay. So some information about performance around generics. So this is where you have to kind of dive in and understand what we're actually doing to implement generics. The first principle is, if you're in the situation today that I described where you're creating your own strongly typed collections or your own strongly typed types, then generics are going to be better. kind of flat out generics are better than you creating your own types. So that's an easy one. If you're not creating your own types, but you're being loosely typed and you're just kind of providing a crappy experience, okay, so is it better to use generics or not? And if the types for generics that you're using for generics are reference types, then it's almost always a wash. I mean, it's almost always worth it to provide the generic types because, like list of T, where T is a reference type, the runtime essentially has to construct that type. We have to. It's like we're generating the code for that type. And for reference types, because all references have the same layout in memory, they're essentially just a reference or a pointer, as we talked about earlier. We can do one instance of list of blah, where blah is a reference type. One instance of list of T, where T is a reference type, we have one instance of that. But for value types, well, all value types are different in terms of the layout. The size of the value types is different. So we have to construct a different list of blah for every value type you do. So list of int, list of double, list of uranum, myanum, whatever. Each one has a separate instantiation of that class. So the implication of that is that it's still okay to have generics over value types, but what you should be thinking is when you type in that code, list of int, it gets new list of int, that you should say, oh, okay, this is like I just created a whole new collection class. Is that warranted in this case? And if it is, then great. If it's not, then you should think harder about it. Okay, so just very high level principles around the generic collection classes is that's where I think the most common uses of generics are. We have the set of worker collections that you might expect. We have a growable array called list of T. We have a dictionary stack and queue. And generally speaking, these should not show up in your public APIs. These are for your developers to use in the implementation of their code. And then we have a set of collections that are for object models. So we have for when you're returning a collection, so as some kind of out parameter, so the return type of a property, for example, we have collection, read-only collection, which doesn't allow adding and removing members, and then a dictionary type. So those are for returning. And then if you want to take in, we have these for accepting parameters that are interface-based, so you can take in a wider range of collection types. Okay, so arrays are the next thing to talk about here. So arrays are kind of have a couple of little quirks to them. So we talk about one of those quirks. So the first thing is you should not return internal instances of an array. So we actually had this problem in V1 of the framework with invalid path chars, where we had this private static array called bad chars, and it listed all the characters, all the Unicode code points that were not valid for a path. And then what we did is we had a property or a method that just returned that instance. We returned that internal instance. And because arrays are mutable, then people could just change that instance. So if you look at the code here, all they have to do is get the return. Oh, thank you very much. You handed me a pointer to your internal data structure. Okay, now I'll go through and change, instead of 0 being the slash or whatever, the comma character, I'll make it be an A. And then it's a little bit of a security issue because we actually use that to validate paths. And if you kind of instead of making dot be an illegal character, you make it be W, then I can pass ... in and you'll kind of let me get outside of some isolated directory perhaps. So so that's a bad thing, and it's very easy to fix. I think the easiest to fix solution is just return a copy. You should be aware when you're turning actually any mutable instance. You should be aware when you're returning it that they could modify it, and arrays are mutable instances. So one easy fix of it is essentially do some kind of tear off or copy the the entire array and give them a copy, and they can party on that copy if they want to. Or you could use strong type. You could use generics in this case and use a read-only collection, and that would be good. Okay, so the next thing people try to do is say, oh, C# got this read-only keyword. I'll use the read-only arrays and things will be all better, right? Well, not exactly. So, so here's the next thing that people try to do is say, okay, well, forget that. I'll just have a public static read-only field, and I'll return that. But the thing is, read-only applies to the location in memory. That location is read-only. Now, what you store to that location is this mutable type, this type that you can change its state. So, so what it means is, okay, fine, I cannot create a new array and push it into you, but what I can do is change every element of your array to another array, I mean, to another value. So it's essentially the same thing. So remember that read-only only works for types that are immutable. I mean, it's fine to have a read-only string because string's immutable. Nobody can change the value there. But it's not very good for like a string builder, which is mutable. So you should think about any types you have in your system that are mutable. If you ever see them with read-only by there, then there's some kind of issue that you should address. Okay, so this is a question I get asked a bit is, so if I have a property or a method that returns a collection or an array, and there are no elements, there are no items in that collection or array, should I return null or an empty array or an empty collection? And essentially the argument is another kind of perf productivity kind of argument, I believe. And the perf argument goes, well, I can tell that there's going to be no items in this array, so I'd have to construct a whole new instance. I'd have to say new foo array with no elements and return it, and that would just be a waste to do that allocation. So that's the perf argument. Then the usability argument is kind of what I've outlined here, which is, but yeah, if you don't do that, then it would be surprising to developers. Developer expectation would be missed. So, for example, just one example is if I'm for eaching over the characters in a string, and that string happens to come from t.name. If t.name returns null, then this thing is going to throw some null reference exception. And I'm going to look at t. I'm going to say, is t null? No. Okay, is c null? No, it's a value type. What was null here? So it'll take a little while for developers to figure out, and then they'll have to add some special. If t.name is not null, then for each, and there was really no reason. If you would just return an empty instance, then the body of the loop wouldn't have executed, and the logic would have worked out just fine in this program, and it would have been simpler for everybody. So, but to respond to the performance discussion we had around it, for the first thing is it's very cheap to create these small, short-lived objects. It's generally speaking not a big performance problem. But if it's going to be super common and it's kind of a broad thing across your API, then we have a pattern for that. We have this empty pattern. You notice it on array, not array, but on string and on type. Type has it. And that is like we have string.empty, which is an empty instance. So we just allocate one on startup, and we say, okay, that's going to be the one. And you can always just return string.empty. And that's no more expensive. There's no extra allocation there. Okay. Okay, so some performance, while we're still on performance here. I include this not so much that you deeply internalize this particular example, but to make a meta point about where you are on the stack. So most of you, I assume for your career, have worked in languages like C and C++, where what happens is the compiler generates some x86 instructions that are executed and run. And you can do a fair amount of optimization by looking at the x86 instructions that get generated and kind of know what happens. Now you're in an environment where the compiler generates some IL that then the runtime transfers into x86 that then gets run. So you're one level higher up in the stack. So doing optimizations that you have to be very careful about the optimizations that you do at your level. In fact, I think Rico will address this, but there's a bunch of optimizations you need to do, but it's a different kind of optimization than this one. So what happens here is a developer actually tried to optimize the code and made it net worse overall. So what happened is in the top box, I cached the results of calling a.length away, so I wouldn't have to call that property more than once. And then I iterated through this loop. And there was some savings by doing that caching, but the loop ran slower overall. Do you know why the loop ran slower overall than this kind of simpler example or example below? Yeah. Right. It has to do with, his point was it has to do with bounds checking. So the CLR has this great feature where it does array bounds checking. So you've heard of buffer overruns. With managed arrays, it's not a problem because the runtime actually checks the bounds. Every time you index into an array, it says, well, are you going to walk off the end? No. Then it lets you do it. If you would walk off the end of the array, then it throws an exception. But that's a check. That's an if check, and that's somewhat expensive. So what we try to do is hoist those array bounds checks outside when the JIT compiler can recognize what you're doing. When it can prove that you never ask for anything larger than the length, then it can hoist those out. So, so in the bottom case, we've taught the JIT how to recognize that in this case. And so it'll hoist the bounds check out and be net cheaper. In this case, we could teach the JIT to do this. Frankly, we might have already. I don't know. I doubt we have, but we could in the future, but we haven't right yet taught the JIT how to deal with this case. So it'll still have the bounds check, and your optimization will actually defeat an optimization further down the stack. So the lesson here, unfortunately, the next slide doesn't list, here are the kind of JIT optimizations you should be aware of, because we want to be free to modify that list over time as we get smarter. The thing that the high-level takeaway I want you to make is, if you are making optimizations like this, then you need to be understanding how to inspect the x86 or the machine code that the JIT's actually generating, so you can understand what is going on in the system. So there are some documents. We can talk to Rico when he gets here about how to go do that. Right here.
For arrays only.
Yes.
Every time you put .let, it actually does hold the property,
Right.
which it also actually hold x86.
Yes.
Doesn't optimize any bounds.
Yes. So his point is,
The first line of the slide is actually not correct. It says do not cache string or array length, only for arrays.
okay, so I buy your, okay, so I think what you're, okay, so I think I know what you're saying. So what you're saying is that the JIT does this optimization for arrays and not for strings. So I trust you, but I'll have to go back and double check because I got this somewhere, but. Okay. Okay, I mean, I don't doubt you. It's just that it's a complicated system. So let me go back and double check whether strings really apply here or not. The thing is about the debugger that makes your life a little bit harder is that the JIT generates different code when it says debugger or not. So, but okay, you're probably right. I'll go back and double check and post an update if I need to.
Another question. So there is no chance that the code inside the loop will change the length of the array, or do you have any checks to verify that the code inside the loop will never change that length?
The length, his question is, can the code inside the loop change the length of the array? The length of the array is kind of baked in when you created the array, so you can't change it. You can't change the length of the array. I mean, you see what I mean? Like, when you created it, you said it was a 5-element array.
So I guess that's another point, that then that really does apply only to regular arrays, not strings.
Yeah. Yep. Like I said, I need to go back and double check, but he's probably right. Yeah. Yeah. Definitely for collections, you're right. The JIT doesn't do any optimizations for collections. Okay, so exceptions. What are we doing? Okay, so exceptions. So some terminology here. We talk about exceptions as being thrown. That's kind of the term we typically use. We suffix all exceptions with exception. I think that's important because they stand out in the inheritance hierarchy. They stand out when you're looking at classes, and you can essentially ignore them or kind of mentally put them in a particular bucket. Generally speaking, the exceptions, we use exceptions rather than error codes, so errors get noticed. It's interesting when we talk about what the advantages of managed code are, memory management, more robust execution, things like that. It's amazing to me the number of those that can actually be validated or defeated based on what you do. Based on what you as a framework developer do, either we actually get those benefits of managed code or we don't actually get them. There's nothing the CLR is going to do to make it a more productive development environment. It's what you do. And I think error handling is a great example. Nothing in the system keeps you from returning error codes instead of exceptions. You could throw 0 exceptions in your framework. Now, I wouldn't recommend that, but you could do that. And my point is that that would defeat one of the primary benefits we have in the system. So the system, we've decided that with error codes has this inherent problem, and that is that the errors don't get noticed. There's a return value, E failed or SOK, and there's nothing that makes the developer actually check that. In fact, if you pick up Charles Petzel's Programming 132 book and open it up, you might not find those checks if you're. And I know that many of you would always do the checks, but some other developers may not do the checks, and so the errors don't get noticed. And so what happens is you call the API, it failed, return an error result that nobody checked. Some of the return values are bogus, and your program is going to eventually error or crash. But it may happen somewhere else down the line, like 10 frames deeper in the call stack or somewhere in a totally different module. Some crash will happen, and then you have to debug what happened, and you kind of keep working your way up the stack and try to figure out what happened, and it's a much more arduous process. If instead what happened is the error happened and an exception resulted, and the CLR stopped execution of your program, and it gave the caller a chance to handle that exception. If the caller doesn't handle it, it gives his caller a chance to handle it. If he doesn't handle it, it gives his caller a chance. And if nobody handles it, we terminate the program. Because it's much better to terminate the program than it is to let it muddle on with possibly incorrect and erroneous data. So some bits on exception. It's always, so that's kind of some mom and apple pie stuff, but it kind of the devil's in the details with exceptions. So one thing that that we do is there one thing that I've seen done before is that you have, okay, fine, exceptions, great. I'm told I have to use exceptions. I'll have one exception and stick all my error and have a field in there called error code. And then I'll just throw this exception. And, well, now, okay, letter of the law, technically you've met it, but have you really met the spirit of it? Because now as I'm dealing with your exceptions, I catch this foo exception, and then I have to do another switch to see if it was argument out of range or out of memory or blah, 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 when there are already existing exceptions for that. So if there are existing exceptions, you should absolutely go use them. And then you should create a new exception every time there's another class of issue that one might handle with the same kind of catch or handle logic. Instead of glumming everything, like I have my feature area and my exception in my feature area. That's probably not a good idea. You should have your feature area, and then you should throw the appropriate exceptions that are defined in the BCL or the rest of the framework, the appropriate exceptions that make sense, that are common. And then you should create new exceptions based on the cases that are not covered in there. So just some implementation advice. I try to not spend too much time. Okay, yeah.
So if you don't create new exception, so if you actually write all the volumes to be aware about your implementation, how do they know that you open temporary file and get all I/O?
Well, so his question is, how do we let how should callers know that some implementation detail that we're actually using some temporary file here that's not actually important to my callers? And we actually address that in a couple of slides. There's a pattern for that. But I agree with your principle. So some implementation stuff, I try to steer clear a little bit, but I feel like I need to say some bits about it. In your implementation, don't just catch and eat an exception. By catch and eat, I mean you say catch exception or just catch, and then you completely handle the exception and throw it away. The problem with that is that especially if you're lower down in the stack of the framework, you probably don't have enough context to completely handle the exception. It's much more common that what you want to do is catch the exception and do some cleanup and then rethrow it, or just have a finally that when an exception gets done, you do some cleanup logic on it. So an example of this is file.exists. So if you check if file exists and you are out of memory on the machine, if file exists, you're out of memory, you get false. The file doesn't exist. Or, file exists and it throws a, there's some kind of thread synchronization problem, you'll get false. You won't get thread synchronization exception, you'll get false. So that's because we catch and eat the exception in file exists. So now there may be some exceptions that we could handle, like, possibly some security exceptions. And we might say, look, for you, the file doesn't exist because you don't have permissions to even ask the question. So I'm just going to tell you false. Okay, maybe there's an argument to be made there, but certainly not for all exceptions. Yeah. So you're asking what kinds of exceptions are too specific and what kinds of things are too vague. And I do address that a little bit, but ask again if you don't feel like it's been fully covered. Okay. So another one just to pick on here a little bit is system URI. In V1, this class didn't have a way to check for is valid. So there's no way to, given this string that I've typed in, like in IE or whatever, is that actually a well-formed URL or not? And it turns out that's a really common operation. You often want to have a text box and users type something in and you want to validate, just is it the right format of a URI? And I saw lots of code that looks something like this. You have to do try and then return new URI, blah, 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 kind of optimistically, maybe the user typed it in right, and then catch some exception and return the URI. Okay, maybe the path wasn't a full path. Maybe it needs to be expanded somehow. Okay, we try that again. Okay, that didn't work. Okay, catch another exception and try this other thing. It gets really onerous. So the thing that you should do as an API designer is make sure that you can always provide a success code path. You need to be able to draw a line kind of through your API and be able to say, look, you can go down this path without ever getting an exception. You can write this check and then do this. Now you might say, okay, if there's this super uncommon race condition, you'll still get an exception. But at least in the mainstream case, this path never throws an exception. In fact, there's a performance counter that checks when exceptions are thrown, even if they're thrown and caught somewhere else. So I encourage you to see if you can write kind of some base level scenario with your framework so it doesn't ever throw an exception. And I have a couple of reasons for suggesting that. One is there's just a performance problem. We've designed the runtime, and in some senses, the operating system in the silicon is designed the same, with a similar philosophy, where we are going to optimize the heck out of a success code path. That is just going to keep getting relatively faster and faster. the exception code path will get relatively slower and slower because the optimizations that is going on across the stack. So so there's a performance problem, and there's also a programming model problem. I mean, if what you're doing is some kind of branching structure, if what you want to do is branching, well, we have if statements for branching. You know, we have ways to do that. Those already exist in the system. Exception handling is not meant to be kind of a newfangledy way to do branching. We already have those mechanisms. We should just use those. Exception handling code gets really spaghetti-like very quickly, so you should constrain it for really error handling circumstances. So I don't actually have it on the slide, but a totally separate interesting point about exceptions. This catch clause, is anybody familiar with what this catch clause with no exceptions is significant? Why it's significant? It's kind of in the did you know category. Yeah. Yeah, you caught everything, but okay, I could just do catch exception E. Is that the same? Is this the same as catch exception?
No, it's not.
Okay, well, you go ahead.
No, it's not. It also catches native exceptions or exceptions that are thrown by unmanaged code.
No, catch exception will catch exceptions thrown by native code, unmanaged code. They get thrown as an external subclass of external exception, which is a subclass of exception, so it would get caught. Yeah.
I'm not sure if it's other throwable objects besides exception. This catch all.
Right. Your intuition is a good one. His is, are there other throwable objects other than exception? And that's the right intuition. Turns out that the C++ language, any C++ language experts in the room, can you throw 5? Could you throw string in C++? Would that like work? Now, frankly, I'm not sure why, and that's a good thing to do. But we needed C++ on the runtime, so the runtime supports that. So you can't do it in C++, you can't do it in C#, and you can't do it in VB, but I'm pretty sure you can do it in C++, and I'm positive I've done it. You can do it with just the IL. You can throw new string, and it'll go. And I think it's significant for you to understand because if you need to do some kind of catch where, look, I am sure I'm catching every exception here, just doing catch exception won't be sufficient. If for some reason you need to catch absolutely every one. Okay, my digression. Okay, so performance, I think we already talked about this, mostly this, but one big difference with exceptions in C++ versus exceptions in the runtime is in C++ on a module-by-module basis, you had to decide whether this was going to be enable exception handling. And that created, you know, different things in the call stack and different frames. And you paid some performance penalty just for ever using exceptions throughout the module. And that is not true with the CLR. One way to look at it is you've paid for exceptions. You've already paid for it. You don't get an option, so you might as well use them. There's no additional. Just having a throw or catch clause there's no performance problem with that at all. So have the right performance. I mean, have the right throws and catch clauses and things. But actually throwing the exception is an expensive operation, as we talked about earlier. Yep, and so we talked about that stuff. Okay, so some more on the on this concept of providing an success code path. So this is one that I had some personal experience with. Just like the URI example, we didn't really have a way to validate whether a string was actually a valid string. I mean, we had this N32 parse got, but then if it failed, it threw an exception. And that wasn't so great because then you had to catch the exception and do something. So instead, we introduced this try parse pattern. And in general, the design guidelines have this whole try XXX pattern. And I encourage you to use it for cases where you need to avoid the exception. So we have this try pattern that returns a bool and has this out parameter. And it allows a success code path without exceptions in the system at all.
How come one only flow, a legal flow has a good
Yeah, so his question was only float has it and nothing else. And that was just pure scheduling reasons. We kind of had to prioritize them. And I thought we did float and double and 1-1. And then we've kind of rounded it out, and we have all of them. Okay, so I've talked a little bit about it, but kind of the soundbite guidance is you should use try finally about 10 times as often as you do try catch. And in fact, if you look at the number of a number of code expansion things I'm going to show you tomorrow, a bunch of them expand to try finally because it's such a common construct that you should use. What the big difference is with try finally is it allows when an exception or any time there's a place to do your common cleanup logic, whether the exception happens or not. But try catch kind of you eat the exception or completely handle it. The other pattern I mentioned was this catch and rethrow. And the catch and rethrow is fine. It's the same thing as try finally. As long as the exception kind of bubbles back out and you continue to pass the error on, it's good. But this gentleman over here asked earlier about, hey, if I'm using some temporary file, and that's an implementation detail, I don't want to say, hey, throw the disk full exception, but I may want to throw some, I cannot complete the transaction exception. What do I do? Well, I think this is a really common pattern where you do a try, do your operation, catch the specific exception you know could result, and then do your cleanup work, and then say throw new, and then whatever the exception that the user would understand better. But then you include your exception as a nested exception in there, and that actually shows up in the debugger. And if somebody has sufficient kind of understanding of the system, they know the initial problem, and they can drill into the chain of what happened here, here, and here. So it's important to complete that chain. Yeah.
It becomes a security problem.
Yes. So his question is, when is it a security problem to give too much details in the exception? I have a point on it later in the slide, but absolutely, exceptions are another path out of your API. Just like you wouldn't return the username, you can't have the username in an exception either. So I think the biggest issue there is personally identifiable information. Things like paths and things like that, where a username or an application install name might be installed, you should be very careful about how those leak out of your thing through exceptions, through the message text. This earlier was asked, when should you create your own exception classes? And I mean, the high-level guidance is you should create different exception class. So the first rule, use an existing exception class if it exists. If you have a new construct that doesn't exist or it's specific to your thing, how do you know if you glom them together as one exception or have two? And the rule around that is you should separate them if you're doing a different kind of cleanup work. So if two different failures could happen, and like for one failure, the 80% case is the user will log this one, and the other one, the user will have to terminate the transaction completely because that's a totally different kind of failure. If there are different kinds of cleanup logic, then have two different kinds of exceptions. If it's roughly, it's the same, the cleanup is going to be the same no matter what. It's fine to have an exception with some additional data on it, but it is sort of unlikely that you have one exception with all failure cases in it. You should really dissect it and decide what the user scenarios are. Yeah. Okay. So the question is, when would you wrap an exception and when would you pass on? You should wrap an exception if your user, your developer calling your API, will not understand that exception. So, for example, if you're writing some kind of banking system and you need to deposit $12 into the bank, and you use some temporary file to do some calculation in or something, and that file can't be created, and I said the method was add $5, and you threw a file not found exception, I'd be like, wow, what does files have to do with add $5? But if you said through a can't find, can't complete transaction exception, okay, I kind of get that a little bit better. Well, so his concrete question is, should I wrap the socket exception or pass it on? Well, it depends on what your users expect. If you believe that your users kind of get socket exceptions and know that that's what's happening, it's kind of transparent, then it's fine to bubble it through. In fact, preferred to bubble it through. But if you're building like something that the users might not even think of as doing networking, then you might not bubble it through. You might kind of encapsulate it in something. So you really have to try and get in the heads of the users using your thing. And err on the side of not, I would definitely in this case err on the side of not wrapping these things. Okay. Yes. Okay. So creating new exceptions. So the only other advice is, generally speaking, I prefer shallow hierarchies. So if you have like 8 exceptions in your thing and this root exception, then I think you might want to rethink collapsing them. So just like I think if you have 1 exception for your system, it's probably bad. If you have 50, that's probably a bad extreme as well, just as a knee jerk. So we talked a little bit about this, but for error messages, I do think you should localize the error messages. I get a lot of pushback for that because people are like, hey, man, end users aren't going to understand the error messages anyway. It's true. The error messages are not really for the end user. In most of the cases, the error messages are for the developer or, in the worst case, some admin. But it turns out that there are lots of developers that don't speak English. And so, we localize Visual Studio to 20+ languages. We should localize error messages as well. So it's I just looked at the FXCOP violations for Longhorn, and this is the number 2 violation. Is error messages for exceptions are not localized. So I think it's a big problem. We're going to have to go back through and clean up all the code in Longhorn to make sure that it does that. This may sound a little bit pedantic, but use complete sentences that end in a period in your error messages. In fact, I advise you to work with a PM and UE person in your area and have them write or help you write the exception error messages. They really have to be something that'll be meaningful. And then, as somebody mentioned earlier, don't expose privacy information. So, so when you're creating new exceptions, you should always use this exception pattern. This pattern of these 3, possibly 4 exceptions. And the reason why it's so important is that vast majority of exception usage is throw, new, foo exception. And the constructor is really the only thing that gets called. So if the constructors are not common in terms of what they do, then we don't have any commonality with exceptions. So unfortunately, I can't, when I built system.exception, I can't make you have those constructors. I can't like make the constructors abstract or something like that to make you have them on your class. It has to be something you introduce on your class. So we have to have this pattern that says every exception should just have these 3. Definitely the first 3 and probably the last one as well. Yeah.
In addition to having exception at the end of the exception class, is there any other guideline for naming exceptions? Like, can it have verbs and any other guideline?
Yeah, I mean, I'd have to think about it. In general, exceptions are classes and should probably be nouns, but we might have to look at some examples.
Like, for example, you just gave that one, can complete transaction exception.
Yeah, I don't know if that was a good name. We could talk about it some more. Okay, so I just want to show you this example for a couple of reasons. One is it's one I made, or one I participated in making, and the other just shows you about how the guidelines in general are so important. So we defined this argument null exception. We said, you know what, forget the guidelines. For argument null exception, message is not the most important thing. It's the argument name, like foo or bar, whatever the argument name is. That's most important, and the message is secondary. So let's just kind of buck the system and have these constructors instead of the others. So what do you think happened? You might have actually experienced it. I actually got an email from somebody on the Indigo team the other day where they said, you know, a huge percentage of their error messages in Indigo were coming out like this, where it says, you know, argument null exception, the value cannot be null, parameter name, the value must be passed, you know, kind of a very bizarre error message because it says parameter name. Essentially, because both of those are strings, we've embedded in users' mind that it goes message first. So they put the message in first, even though the parameter name was actually called parameter. You see what I mean? So the users throw new argument null exception, and they give a message there instead of the parameter name where they were intended to put parameter name. So this is a place where we actually thought we were optimizing. We thought locally about the problem. We thought, well, it's the best thing for argument null exception. If our users are only ever using argument null exception, that will be the best thing. But it turns out our users are throwing argument null exceptions and file not found exceptions and foo exceptions, and it's much more important how it works in the overall system. Okay, so attributes. Custom attributes are essentially the .NET way of providing new declarative metadata in the system. So how many of you actually had to create a new custom attribute? Okay, only a very few of you. Okay, so I'm going to kind of breeze through this a little bit. So just give you an example of a custom attribute here. The category description and browsable and DLL import are all examples of usages of custom attributes. So they're actually, the custom attribute is the class that defines the browsable bit or the description bit. And we'll talk about how to build those. So a couple things. One is we do suffix attribute with attribute, and we do that for the same reason we do exceptions. We want them to kind of stick out in an inheritance hierarchy or a list of classes so that you can kind of hone in on the other ones and ignore these for the most part. If you're going to be looking these things up at runtime, you're going to use reflection to look them up, then it's a bit cheaper if they're sealed because reflection can go down a different code path there. So we're going to talk a little bit about the attribute usage attribute that specifies where the attribute can be used. And if you need to specify that completely and not use the defaults. And you need to be very restrictive in terms of where it can be used. Only allow it to be used where it actually makes sense. You can always add more later. Okay, so that's the attribute usage attribute. By default, attribute targets is all. But that's kind of weird. Then a developer puts it on a parameter, on a return value, and you don't intend it to be used there. There's no kind of compile time check. But if you specify it exactly, then there'll be a compile time check that helps developers figure out how to use your custom attribute. Inherited is about whether it follows the class hierarchy or not, and allow multiple is whether it accumulates or not. Okay, so there are two kinds of parameters. There are positional and named. Constructor arguments, we really want to have some of the arguments are optional and some are required. So the positional ones are required and the optional ones are named. I think it's easiest to look at an example here. So I have this name attribute, and it's as I have required username. I always want you to specify the username. And so it's a positional argument. And notice there's an argument on the constructor, and then there's a read-only property that corresponds. It's important to have both those because if you don't have both those, then you can't actually suck the value out. You can't actually reflect on it and get that value, and you might need that. And then the optional one is age. So yeah, you can specify the age if you want to or not. You know, doesn't really matter. That is better to be modeled as a read-write property. And then that's the usage syntax below. And you see, it's a little bit bizarre, you know, because you don't usually see that in C# code with the being able to set the properties right in line there. But that's how it works for custom attributes. So I want to give this real quick example of kind of bad design, real world problem that we had, mainly just to show you a couple of examples of using custom attributes, but a little bit about CLS as well. So we had this class called assembly flags, and assembly flags has this uint for flags, and the flags are some things that are about the metadata file layout, and in the metadata format it was typed as a uint, so the developer typed it as a uint in the public API, and of course they got the CLS compliance warning because uint's not in the CLS because some languages don't support unsigned types. So the fix is they just put CLS compliant false. They just slapped CLS compliant false on there, but didn't provide a compliant alternative. So they didn't provide another way to access that or kind of rethink that way. Is there any way they could expose it in a compliant way? They just kind of make the warning go away and move on without sort of understanding what the problem was. And then after we shipped V1, we get this call from somebody, some Visual Basic user that says, hey, I want to use this API, but I can't because it uses this unsigned types that I can't access. So we're like, okay, yep, we made a mistake there. So we have to fix it. But because it's a property name, we can't differ only in return type. We have to pick a new property name. So the change ended up being kind of painful in terms of the API surface here. So what we had to do is obsolete the CLS compliant false ones and add compliant versions with different names. So I think the moral of this story is just to not ignore the error messages, but actually try to address them as you can right up front. Okay, so I got to shoot through here. Static classes. Static classes are classes that just contain static members. They're utility or helper kinds of classes in the system. They're really not the center point of your design. Some people that are coming from the Win32 world, they might feel real at home. You know, I'm just going to have one big class. I'm going to have all these entry points in it, and that wouldn't be the right approach. Again, it's a balance thing we need to reach here with static classes. They're really good for some things, but they shouldn't be the center point. So let me give you one of these under the covers things. C# just added the keyword static classes, so you can put static on a class, and what it does is enforce that your classes only have static members on them. And I'll give you the actual motivating example for why C# added that in a bit. But you can see what it does is it actually makes the class sealed and abstract, and it doesn't emit a constructor at all. So it's abstract, it can't be constructed, and it enforces that every method's actually static. So that's goodness. So these should be used, again, like with all classes, just like I said with enums. Static classes can gather the moss. They can, I have this static class sitting there. Oh, let's just throw that other method on there. Throw that other method on there. I frankly think we're struggling with that around system.environment right now. That class, you know, environment. Yeah, this thing is in our environment thing. So we got to add new members to it. And static classes are typically sealed. We have and the C# static kind of does this thing for you, and it has no instance members on there. So just to give you an example, the bad design here, the has shutdown started. We actually shipped this thing in V1 with this member called has shutdown started. And it was on a static class, but it was an instance member. It's before C# had that support. So it was kind of late in the game in V1. We realized we needed this property. All it was, you know, there was a method in the E we had to call and return the result. So it means that the developer checked this in without ever calling it, right? Because it's an instance member of a static class that you can't create. Right, so you could not possibly call this member. So the developer checked it in with no unit test, never even trying to call the method. The tester signed off on it. It worked great. I don't know how they called it. The PM that wrote the spec looked at it, thought it worked great. It's got docs for it. You know, the UE person looked at it, thought it looked good, kind of wrote the docs for it. So all kind of a big system failure around it. So this is the example of why why we needed to have actual language support for this particular pattern. Okay, so we're kind of at the end of our time here. So what I want to do is so what we have here is a few examples, and what I want to do is you can take a few minutes now and work with people by your desk and kind of answer these questions on the first slide and then code review the rest of them. And then we'll break for lunch, and just to remind you that 15-minute window there. We'll at like 12 we'll start a usability presentation, and you're welcome to grab lunch and come back for it, or you're okay. So we're going to go through the exercises now. So what the idea with this one is we want to know what kind of type to use. So did you want to use a reference type, a value type, an enum, custom attribute? What kind of type? So for a type that represents a document, some kind of type that's going to encapsulate a document, what might you use there? A reference type? Yeah. So why are you saying reference type? Say it again.
Document can be used, and it's not like value might be.
Yeah, the document it might be big. It might be, you might have to copy the thing around a lot. So holding just a reference to that thing seems like a good idea. Yeah, and it's kind of the default thing, so that, if nothing else seems better, that's a good thing to do. So how about a type that represents a rational number? Do you know what I mean by that, like with the whole I thing? What might you use there? Yeah, so I'm hearing value type. Some people are suggesting value type. Yeah, I think that's good. Why? Somebody want to raise their hand, or no one's going to stand up and, yeah.
Less than 16 bytes.
Yes, it's very likely less than 16 bytes. Yeah? Yeah, I would think it should be immutable. That's what he's saying. Yeah, I agree. I mean, you could probably do it another way, but I think it makes a lot of sense for this to be immutable. Any other reasons? Yeah, I mean, it kind of feels like one of the built-in types, right? Like int, double, rational. Yeah, I mean, they're all kind of the same thing. How about if I needed a type that I use to mark other types as serializable? I wasn't really creative on this one, sorry. An interface, okay. Why are you saying interface?
So that whoever wants to actually be serializable can just implement this interface. That would be like
Yeah, an interface might work. Okay, but what? Any other suggestions? Attributes. Why attributes?
You can find out types.
Yeah, you could use reflection to find. I might argue that's expensive, but yeah. Say it one more time. I didn't quite catch it.
If I don't need to implement some make the type serialized,
Yeah.
it's more
Yes. Yeah, what he's saying is, look, there's this debate between whether I should use an interface for this or a custom attribute. And the interface that was described earlier was kind of like a marker interface. The interface doesn't have any members on it. You're just kind of using it to mark this type. And for the most part, I agree with the gentleman's comment over here, which was that it's a little bit kind of more mainstream to use a custom attribute for that, to kind of mark some additional bit of metadata. You should use an interface when there's a contract associated with it, when there's some kind of requirements that you do certain things. Then an interface makes more sense. But I will give you that it is actually cheaper to find out whether a type implements an interface. That's a fairly cheap call. To find out whether a type has a custom attribute on it is a little bit more expensive. So that might weigh in as well. Okay, and now for the code review parts of this. So you have this days a week. Somebody wants to check in this code. What kind of advice do you give them? Use an enum. Why does an enum make sense?
You're just storing ends.
Yeah, it's just ints. Okay. Any other reasons? It's not a class. What do you mean by it's not a class? And why is it not a class? I see. Yes. So what he's saying is, okay, let's say I have an API that takes a day a week, like schedules a meeting or something on a particular day of week. I got to type that thing as taking an int. Okay, now I have to remember that, let's see, Sunday was 7 and Monday was 2. I mean, you can't remember those. Within enum, they're well defined. IntelliSense helps you get that thing right. Yeah, so I think that's a pretty compelling reason. Any other comments on this one? Any other things that are wrong here? The name? What don't you like about the name? Days of the week. Yeah, it does feel like a little wordy. Where this isn't Scrabble. We're not trying to get as many sort of characters used as possible. You should think about being as brief as possible, but no briefer. No brief. No more brief. Okay, so how about this exception? We actually checked this exception into the tree before we shipped V1. It was like right before the 2000 PDC. Our test manager found out we had a printers on fire exception and made us rip it out. So
It's also an
very
inside
clear.
joke with Linux or something, isn't it?
Yeah, well, there is an inside joke around, I think HP or something, or one of the Unix things actually ships with this actual, it's like an error code or something. So there is, in some of the Unix kernels, an actual error code for the printer is on fire. I'm not sure exactly what you do when you get that, but we almost shipped this. But so if we were going to ship it, what would we do to fix it? We would rename it. Okay, somebody's saying rename it. Okay, good. Anything else? Yeah, the first parameter should be message. So we're about to make that same mistake we made before with argument null exception of saying, oh, well, the most important thing in my little world is the printer name. But unfortunately, you're not the only exception in the world, so you have to kind of play with the rest of the exceptions. And the pattern there is no arguments, message, comma, nested exception or inner exception. So yeah, you should follow that pattern. Any other comments on this one?
Well, about the name, it should be end in exception regardless of the start, right?
Yes, that's a very good point. So what he's saying is regarding the name, it should end in exception. All exceptions end in exception regardless of how catastrophic the exception is. Exception is more than enough identification that it's a bad thing. So it shouldn't end in error, it should end in exception. Any other comments? So one thing that was asked during the break, and I'll point it out here, is I kind of glossed over it. The fourth constructor listed on the exception pattern is actually the serializable constructor. It's the constructor that's needed for runtime serialization. And I do think that most, at least many exceptions should have that, because any call that could go across the remoting boundary, if the exception isn't serializable, then that could cause a problem when calls go across the remoting boundary, even in process. So as a general rule, it's good practice to make your exceptions serializable. We certainly do that for any exception that we think is mainstream and broadly applicable. Okay, how about this guy? What's wrong with this? Okay, so somebody's telling me it should be powers of 2. That's true. Or that's one possible fix, I should say. Other thoughts? Yeah, back in the back. Yeah, okay, that's a good question. You might take a step back here and say, how do you want to use this color object? Did you want to OR those things together? Are you kind of mixing paint? Is that what's going on? Okay, then maybe you need that. But if you're just trying to set the ends of a gradient fill to be different colors, then you may only need one. So I agree. Probably in this case, you can just nuke flags. Let's assume we just nuke flags so we don't do the powers of 2. What do we do, though? Say again?
You want to give specific numbers for each one of them?
Yes, I want to go ahead and define right now what the numbers is. I mean, if I don't do it, the compiler will do it on my behalf, so it'll happen. But I want to go ahead and control the numbers and have them explicitly in the source code such that if later, I come through and alphabetize the source code or add a new value or something, I don't end up breaking anybody. So go through and explicitly add them. Yeah.
Allow then not explicit numbering at all.
Well, okay, so the question is, well, okay, if that's the advice, how come C# even lets you do it without explicit numbering? And I think that's because C# has to serve two masters, and one master is you guys, the guys building platform APIs that ship, and you have a certain set of need of power and control. Then another class of users, application writers, that they just need to get the job done. Like, nobody else is consuming this API but me. It's only in my compilation unit. And for them, it doesn't matter. They reorder their source code. They're going to recompile the whole thing anyway. So it kind of is a balance. And it's, I mean, for good or for bad, I think that if you want to serve the second camp, you kind of have to err on that side, because that second camp, I'm never going to get those people in a room and explain to them kind of how to make something easier. It just needs to be easier by default. But you people, I can get in a room and explain to you how to make it more resilient. Yeah.
Is it color or colors?
Okay, good question. Is it color or colors? How do you know which it is? Yeah, but okay, but how do you know?
It's not returning many. I mean,
Okay, yeah, we talked about the returning many or not thing in terms of like property and method names. That's true, but in terms of type names, that's a little, or enum names in particular, it's a little different.
Well, if it does have the flags, you could have multiple colors.
Right. Now that's the key thing. Anything, what he said is, if it's a flags, it could have multiple colors. So that's the key point. Enums that are not flags shouldn't be plural, and enums that are flags should always be plural. Does that make sense? Because flags, kind of, you're trying to, it's like the attribute target versus attribute targets thing. You want this guy to be plural. Because, I'm sorry. You want flags to be plural. I think we decided earlier we'd nuke flags from this, so that means he doesn't need to be plural.
Before you had days of the week.
Yes. So again, right. So if we do the enum, the days of the week, then you do some thinking about where the pluralization goes. But if we decided to make this enum, if we decided to make it a flag, then it would have to be somehow plural. If I were to plural that, I might say day. Just call it days. I mean, is the of the week adding much? I mean, there's all these other kind of days that are not of the week that we need to. So I might just call that days, assuming it's a flag. And if it's not a flag, just call it day. Okay. Okay, sorry here. Okay. File IO path. So what's wrong with this guy? Okay, the IO needs to be uppercase, so that's good. Yeah, probably should be a static class. I mean, if we really intended this guy to be this sort of helper class, it should be static. Any? Yes, okay, so I have get root dir. I don't know what the Google test would tell me for dir, but I doubt it will be directory. So just spell it out. They're not, it doesn't cost you that much more to have those characters. You don't leave developers guessing. Anything else wrong with this guy? I think the main bit is it needs to be explicitly marked as being a static class. Okay, this custom attribute. Attribute is missing was the comment. So code reviewer attribute needs to be suffixed with the attribute suffix. Yep. And then what else? Yeah, it does have overloaded constructor. So what do we do to fix that? Yep. Okay, so make a suggestion. Okay.
So I think what I might do in this case is actually the level may not be important to me all the time. So I would whack the second constructor.
Okay, so he's saying he'd whack the second constructor.
And I just have the property of the level.
Okay, right. So I think that's the simplest fix to this is what we're saying is that the string alias, that guy's required. He's always needed. So I have the constructor for it, and then the property for that. And a level is optional, so I have a get set property for it. So are there any other problems with this? There's at least one more I see. Oh, that's a good point. He said the attribute usage block. You should have the attribute usage and you should fully specify it. Say it again. Yeah, what we're seeing is that, look, the constructor parameter name is alias, but then the property name is reviewer alias. So these guys need to match except for by case. So let's pick one. I don't know. Let's go with reviewer alias because it's probably better. So that means the parameter name of the constructor needs to change to reviewer alias. Lowercase r, reviewer alias. Okay? Okay, so the summary from this, we talked about all the different kinds of types and when they should be used and when not, and some of the problems with them. So any other kind of cleanup questions on this section on types? Okay, so we're going to switch now.